The concrete frame was still standing. The steel structure had absolutely not collapsed, but fire was already racing toward the upper floors of the tower. It was not spreading through the interior rooms or the hallways. It was climbing rapidly across the external skin of the building. The surface of this building looked entirely metallic. It looked like pure aluminum. It felt cold to the touch and seemed completely incombustible. So what exactly was feeding these massive flames? This is the ultimate contradiction that has challenged modern architectural engineering. Millions of tourists travel to Dubai every single year to admire a futuristic skyline that defies the harsh desert environment. These towers are the central product of a massive global tourism engine, but the most dangerous part of these magnificent structures cannot be seen from the street level. The aesthetic ambition hides a complex engineering reality. When extreme climate pressure meets a sudden ignition source, the consequences reveal a hidden vulnerability. The illusion of absolute safety is becoming harder to maintain. We are going to dismantle the layers of this engineering mystery. We will discover why a city built to project invincibility is now facing a multi-billion-dollar legacy debt. The real story is not about the sun burning the metal. It is about what the metal was engineered to hide. You are not looking at a solid sheet of aluminum. You are looking at an industrial sandwich engineered to perfectly mimic one. In the early 2000s, rapid real estate expansion required materials that were lightweight and easy to shape. Developers and architects needed a material that could reflect the relentless desert sun while providing a flawless aesthetic finish. Aluminum composite panels became the undisputed standard for wrapping towering hotels and luxury residential blocks. These panels allowed construction crews to build the iconic skyline faster than anywhere else on Earth. But the term aluminum creates a false sense of absolute security in the minds of tourists and residents. If you take a standard panel and turn it sideways, the reality of its construction becomes undeniable. The shiny exterior is incredibly thin. Behind that incredibly thin metal front lies a core of synthetic material. In many older panels, this core is composed heavily of polyethylene or other polymer compounds. These synthetic materials are essentially derived from petroleum products. They offer excellent flexibility and drastically reduce the weight of the massive facade system. But they also possess a significant amount of stored chemical energy. From the street level, no tourist admiring the architectural beauty can distinguish a mineral core from a polymer-rich core. Even a seasoned engineer cannot simply look at a finished wall and know exactly what is sealed inside. The danger does not lie in the metal itself. The vulnerability is locked deep within the chemical composition of the hidden layers. But even the combustible core is not the most dangerous part of this architectural story. The panel is only one piece of a much larger and far more intricate mechanical system. Fire does not attack isolated materials in a laboratory setting. It attacks the entire interconnected building system that was actually constructed on the site. To understand the true risk, we must map the anatomy of a complete external cladding system. When you look at a modern high-rise hotel, you are seeing the final decorative skin. Behind that skin lies a carefully engineered structural gap. This is followed by a heavy layer of thermal insulation. Finally, you reach the solid concrete or steel backbone of the building itself. The components are held together by brackets, adhesives, and structural anchors. If you place a polymer core panel in a certified testing chamber, it might resist a small flame perfectly well for a limited time. The metal front acts as a thermal shield, but when exposed to intense, sustained radiant heat, the physical properties of the system begin to drastically alter. The thin aluminum skin starts to warp and bend under the immense thermal stress. The adhesive binding the metal to the core begins to melt and fail. Once the front layer peels away, the protective shield is completely gone. The fire is no longer attacking an incombustible metal surface. It is now directly attacking everything the metal was supposed to hide. The core material melts, drips, and ignites, creating flaming droplets that can fall and start secondary fires below. This creates a chaotic vertical battlefield that exterior firefighting equipment struggles to reach. The architectural design that made the building look light and futuristic suddenly becomes its greatest liability. The true terror begins when a highly localized incident escapes its boundaries. Imagine a luxury apartment or a high-end hotel room on the 20th floor. A small ignition source appears near the window or on the outdoor balcony. It could be an electrical fault in a piece of outdoor equipment. Heat and thick smoke rapidly accumulate against the glass barrier. Eventually, the window shatters under the thermal pressure, or a balcony fire simply reaches the structural edge. The flames escape the confines of the interior room. The fire curves upward along the exterior wall, seeking oxygen and following the natural fluid dynamics of hot gases. It touches the edge of the aluminum composite panel. Within seconds, the protective outer layer deforms, and the intense heat forces its way into the system. The fire is no longer limited to a single room with a sprinkler system. It has successfully transitioned to the exterior of the building. Hot gases and flames enter a secondary space that most residents do not even know exists. The fire has effectively entered a hidden building wrapped entirely around the visible building. This transition represents the exact moment when traditional interior fire suppression systems become virtually useless. The sprinklers inside the rooms cannot reach the exterior skin. The smoke detectors in the hallways might not even register the danger immediately. The fire is now traveling on the outside, completely bypassing the internal safety zones. The hidden space behind the aluminum panels is not a construction error. It is a deliberate and necessary engineering feature called a ventilation cavity. This continuous gap allows air to circulate, preventing moisture buildup and managing the extreme thermal load from the desert sun. But under the specific conditions of an exterior fire, this vital cavity transforms into a deadly vertical corridor. Hot gases naturally accelerate as they travel upward through a narrow enclosed space. This creates a powerful aerodynamic phenomenon known as the Chimney Effect. The cavity physically pulls the flames higher, feeding the fire with a constant, high-velocity stream of oxygen. The fire races upward behind the beautiful exterior skin, hidden from the direct view of the people inside. To stop this invisible chimney, engineers design specialized barriers called firestops. These barriers are meant to seal the cavity at specific floor intervals, physically blocking the upward path of the flames. They act as closed doors within the hidden structural gap, but the effectiveness of a firestop depends entirely on flawless installation and the use of correct materials. If a barrier is slightly too small, improperly sealed, or completely missing, the chimney effect remains unbroken. If the fire is running rapidly behind the exterior wall, the emergency response teams face an impossible targeting problem. They cannot easily extinguish a fire that is shielded by an armored layer of metal. A facade is not merely a decorative element designed to impress international tourists. Under the wrong conditions, it operates as a high-speed transport system for destructive heat. There is a widespread misconception that the extreme summer climate of Dubai directly causes these buildings to ignite. The ambient outdoor temperature in the Middle East can indeed be brutally high. But the summer heat is absolutely not an ignition match. It does not automatically cause an aluminum facade to burst into spontaneous flames. The role of the climate is much slower, much more systemic, and far more difficult to detect. A modern building in this region faces severe temperature fluctuations between the scorching day and the artificially cooled night. This relentless cycle forces the different material layers of the facade to constantly expand and contract. Over a decade, this continuous movement places tremendous mechanical pressure on the joints, the sealants, and the hidden adhesives. The sun acts as a long-term environmental stressor. It silently degrades the integrity of the protective exterior over many years. The climate is the long prehistory of the facade failure. But when a real fire actually arrives, the scale of thermal energy changes completely. The radiant heat flux from a structural fire is exponentially more intense than normal solar radiation. We must never confuse ambient weather temperatures with the devastating kilowatt energy generated by a concentrated blaze. The extreme environment weakens the defensive armor of the building. Then, a localized accident exploits that exact weakness. This combination creates a perfect storm for a systemic failure. The visual impact of a towering inferno is devastating for any global city. For Dubai, a city whose entire economic model is deeply intertwined with tourism and luxury real estate, the stakes are immeasurably high. Dubai welcomed over 17 million international overnight visitors in a single recent year. These millions of visitors book rooms in high-rise hotels, specifically for the promise of unparalleled luxury and ultimate safety. The hospitality sector operates on very fine margins, relying heavily on high occupancy rates and premium pricing. When a video of a burning skyscraper goes viral on international social media, it directly threatens the core brand of the destination. Tourists do not want to wonder if the beautiful hotel they are sleeping in is wrapped in highly combustible material. They demand absolute peace of mind. Therefore, facade safety is not just a matter of structural engineering. It is a critical pillar of regional economic stability and tourism confidence. If the international market loses faith in the safety of the skyline, the entire economic engine begins to stutter. Investors who purchase luxury apartments expect their assets to remain secure and appreciate in value. A widespread safety crisis would severely disrupt property valuations and rental yields. The pressure on the government and the real estate developers to solve this problem is monumental. They must protect the residents, secure the assets, and defend the global reputation of the tourism industry. The authorities in Dubai did not stand still while these challenges emerged. The city launched a comprehensive counterattack to secure its architectural future. The government fundamentally overhauled the civil defense regulations. They introduced the highly stringent UAE Fire and Life Safety Code of Practice. This comprehensive document redefined the legal requirements for all external cladding systems. The new rules mandated rigorous laboratory testing for any new material entering the market. Architects and developers must now submit exhaustive documentation before a single panel is approved for installation. The regulatory bodies created strict registries of certified products and mandated extensive site inspections. On paper, every single layer of the building skin now has a specific name, a certified fire rating, and a clear chain of legal responsibility. Following these decisive regulatory changes, it seemed the engineering danger had finally been contained. New facades would be strictly reviewed, and newly installed products would be heavily fire-resistant. The government successfully established a robust framework to prevent future architectural mistakes. This regulatory victory provided a necessary wave of reassurance to the international tourism and investment markets. But a laboratory certificate can only describe exactly what was tested in a perfectly controlled environment. The actual implementation in the real world introduces variables that no laboratory can fully predict. This brings us to the most critical realization of the entire investigation. Fire does not attack a piece of paper or a laboratory certificate. It ruthlessly attacks the physical building that was actually constructed by human hands. There is often a massive gap between a perfect test sample and a full-scale facade installed on a busy construction site. The laboratory sample is assembled perfectly by highly trained technicians. The real building has complex corners, challenging window frames, curved balconies, and unpredictable ventilation penetrations. The real building is assembled by workers operating under strict financial deadlines and intense weather conditions. The central investigative question is whether the configuration tested in the lab is identical to the system currently hanging 50 stories above the street. Are the hidden fire barriers perfectly aligned with the floor slabs? Are there accidental gaps in the insulation? Is the adhesive exactly the same chemical mix that was originally approved? Has the building undergone any unrecorded exterior maintenance or superficial repairs over the last 10 years? A perfectly certified panel can still fail catastrophically if it is installed within a deeply flawed structural system. Even the strongest new safety rule faces a massive problem that it simply cannot solve overnight. The new rules only easily apply to the buildings that have not yet been built. The most complex challenge lies entirely with the buildings that were already standing before the new codes were written. This massive inventory of older buildings creates an enormous economic phenomenon known as the facade legacy debt. Hundreds of towers were completed during the massive real estate boom, using materials that met the older, less rigorous standards. The engineering solution for these older buildings is theoretically quite simple. Inspect the existing walls, test the specific materials, and replace the dangerous panels where necessary. But the economic reality of executing that simple engineering solution is incredibly brutal. Who exactly pays the millions of dollars required to strip and replace the skin of a fully operational luxury tower? Is it the original developer, the current property owner, the management company, or the individual residents? For the hospitality sector, the crisis is even more complicated. If a major hotel decides to replace its entire facade, it must erect massive scaffolding. This construction noise and visual disruption destroy the premium guest experience. The hotel risks losing millions in immediate tourism revenue, while simultaneously spending millions on the renovation itself. If they choose to close the building completely during the repair, the financial blow is catastrophic. Determining the exact chemical makeup of a panel that was installed 15 years ago requires invasive physical sampling. You cannot simply look at a wall and know its history. The city is actively navigating this massive financial liability, balancing immediate safety against severe economic disruption. For the people living and staying inside these towers, this is no longer a theoretical debate about material science. It is a highly personal question of whether the wall outside their bedroom can be entirely trusted. We must ground this vast technical and economic analysis in the reality of human experience. Imagine being a guest in a premium suite on the 50th floor of a famous hotel. The internal fire alarm suddenly begins to echo through the building. You open your door and check the main hallway. The corridor is perfectly clear, the lights are on, and there is no visible smoke. Your immediate instinct might be to wait inside, trusting the solid concrete walls of the modern structure. But then you look out your panoramic window and see an aggressive orange glow reflecting off the adjacent glass. The danger is not inside with you. It is rapidly moving up the outside of the building. If the hallway is clear but the exterior is burning, do you trust the evacuation protocol or do you panic? From the perspective of the local emergency responders, an exterior facade fire presents an absolute logistical nightmare. A fire contained inside a room can be precisely targeted by brave firefighters pushing through a doorway. But an exterior fire creates a deadly rain of melting polymer and burning metal falling to the street level. This falling debris severely endangers the first responders and destroys the command zones established below. Furthermore, the path of the exterior fire might not perfectly align with the layout of the interior rooms. The fire can randomly break back into the building multiple floors above the original source. This completely shatters the predictable behavior of a standard structural fire. The human vulnerability becomes deeply exposed in the space between the safe interior and the burning exterior. To reclaim control over this hidden infrastructure, specialized engineers must conduct highly invasive field inspections. The true inspection process goes far beyond simply checking the original paperwork. The question is no longer whether a specific panel brand was certified 10 years ago. The real question is whether the system installed on the wall is still structurally intact today. Inspectors must physically cut into the existing facade of a living building. They extract physical samples of the core material to test its precise chemical response to intense heat. They insert specialized cameras into the dark ventilation cavities to verify the existence of proper fire stops. They critically examine the complex joints around the windows to see if the sealants have degraded under the desert sun. They look for subtle signs of warping, strange adhesive failures, or undocumented maintenance modifications. This small strip of fire-stopping material may be the only thing interrupting the invisible chimney before it reaches the next floor. Every single step of this forensic investigation opens up a new layer of potential liability. A single negative finding can instantly trigger a massive, mandatory replacement project. This investigative process is the only proven way to separate the marketing illusion from the physical reality. It forces the industry to confront the actual condition of its aging assets. The ultimate question is whether a global destination can successfully escape this architectural trap. The answer is yes, but the solution requires tremendous financial commitment and continuous verification. The engineering community absolutely possesses the knowledge to build perfectly safe high-rise facades. The defense strategy relies on multiple, overlapping layers of protection. It starts with selecting highly fire-resistant mineral cores instead of cheap polymer materials. It demands rigorous full-scale testing of the entire proposed assembly, not just the individual components. It requires the precise installation of continuous cavity barriers that can genuinely block the flow of hot gas. Crucially, it demands relentless independent inspection during the actual construction phase to ensure the contractors follow the blueprints. For the existing legacy buildings, The path forward is a prioritized risk assessment. Towers must be categorized based on their height, their occupancy type, and the specific materials currently hiding on their walls. Hospitals and high-density hotels must be addressed with absolute urgency. The problem is not that Dubai lacks modern standards or advanced technology. The real problem is the inevitable gap between a perfect regulation, a flawless design, and a degraded physical reality many years later. The architectural ambition of the city must now be matched by an equally relentless commitment to structural maintenance. From the safety of the street, the towering skyline still projects an image of absolute permanence and wealth. The sweeping facades of glass, concrete, and aluminum appear perfectly sealed, polished, and masterfully controlled. They stand as a brilliant testament to human engineering and economic ambition. But the true safety of a high-rise structure is very rarely determined by its shiny surface. It is ultimately decided by the chemical core, the hidden cavity, the installed barrier, and the tiny structural joints. It is decided by whether the complex system installed a decade ago is genuinely the system that everyone still believes is there. To me, the most deeply disturbing part of this entire investigation is not that our modern engineers lack the right solutions. They absolutely possess the solutions. The real tragedy is that the absolute weakest layer of a building may remain completely invisible until someone pays millions to look for it. Or worse, it remains a secret until a rogue fire inevitably finds it first. The magnificent facades of this global city were originally designed to boldly reflect the desert sun, but the only real test begins when intense heat finally reaches the dark layers that the sun was never supposed to touch. If you value documentaries that dare to look beyond the glittering skyline and investigate the hidden systems governing our world, make sure to subscribe. The next critical warning sign is rarely found where the official tourism brochure tells you to look. This documentary provides an independent systemic analysis based on publicly available data, official safety regulations, and historical engineering reports at the time of research. Economic conditions, building codes, and regional tourism statistics are subject to continuous change and official revision. This video critically examines urban infrastructure, economic pressures, and historical construction practices. It does not intend to target, blame, or disparage any specific residents, private businesses, or demographic groups. The information presented does not constitute individual financial, real estate, or travel advice. Certain structural analyses represent logical deductions formulated from the cited industry sources.